Okay, so let's look at this one here. This one again is a complicated looking one. Looking at it, you really can't tell what's going to happen. So this is 2 to the nth power, and this is n squared. Now again, you might think that this thing goes off to infinity, or maybe it goes to 2, maybe it goes to 1. I don't know. Okay, but let's find out. You might suspect that this is going to grow faster than this, right? So this is an exponential, right? And this is just a squared term. So I don't know. So if you don't know, let's figure it out. So what can we do with this one? Well, let's look at f of x equal to 2 to the x over x squared for all real numbers x. Now, we could take the limit of this thing, right? And then we could use some tools in our toolbox. Watch. So if we take the limit, okay, so if we consider this, and we take the limit as x approaches infinity. And so, well, we'll get to there in a minute. So let's, limit of this, 2 to the x over x squared as x approaches infinity. Now what happens then? Well, this gives us infinity over infinity, which is an indeterminate form. So guess what? We get to use L'Hopital's rule. Okay, so we have an indeterminate form. So what does that mean? Well, we could take the limit of the derivative of the top and the bottom. So by L'Hopital's rule, what do we get? Let me do this. Let me write it down here, over here. We get the limit as x approaches infinity. So the derivative of the top, so it's an exponential, right? So it's going to be 2 to the x. So the outside function, 2 to the x, times the derivative of the inside function, which is 1. But then we also divide by the what? The natural log of the base. Or excuse me, multiply by the natural log of the base. Okay, so remember the general rule for exponentials. When you're taking the derivative of the exponential, it's the derivative of the outside, which is still 2 to the x, right? It's like e to the x. Think about e to the x, okay? But e to the x is simpler than this, but you do the same thing. So it's e to the x times the derivative of the inside function, which in this case is just x, which is the derivative of x is 1. And then you multiply by the log, or the natural log of the base, right? So in this case here, it's going to be 2 to the x times 1, which is 1, but then you're going to multiply, excuse me, by the natural log of 2. And then the bottom one, the derivative of the bottom is just 2x. Okay? Now, what happens to this as we go off to infinity? Well, this is going to go off to infinity, this is going to go off to infinity, this is going off to infinity, so we still get infinity over infinity. So now we're going to do L'Hopital's rule again. And so now, what do we get? Well, this is just a constant, right? So we take the derivative of this. The constant doesn't matter, but we take the derivative of 2 to the x, and so we're going to get another natural log of 2. That's really the only difference. Okay? So this is going to, again, we're going to get derivative of this, which is going to be the derivative, it's going to be 2 to the x times the derivative of x, which is 1, times the natural log of 2. So we're going to get another natural log of 2 in here. So this is going to be the limit as x approaches infinity. And now we get 2 to the x times natural log of 2 squared. And now the derivative of the bottom just gives us 2. Aha! Okay, so now, what do we got? Well, the top is going off to infinity again, and the bottom is a constant. So guess what? This equals infinity, and so this diverges. And so now, since this diverges, the sequence diverges. Okay? And that's it. Have a good day.